So let's just talk about the Kruskals algorithm. So this is similar to the Prim's algorithm. Here also we use this to find the minimum spanning tree in a connected weighted graph. So like an example, this is our connected weighted graph. This graph consists of vertices and edges. So we wanted to create one minimum spanning tree. So this is a subgraph which will contain v dash and e dash, and here the v dash will be equal to v. So that means the minimum spanning tree will contain all the vertices from this graph, but the edge will be number of vertices minus 1. So here we have written all the vertices. Now we're gonna use this Kruskals algorithm to find which of these edges we should take in our minimum spanning tree so that the total weight is the smallest. Now in Kruskals algorithm and also the Prim's algorithm, in both of the algorithm the output will be same, but their approach little different. So here are the steps that we should follow in case of this Kruskals algorithm to find this minimum spanning tree. So here the first step is to remove all the loops and the parallel edges from our graph. So here you can see we have this self loop, so we have to remove this edge. So we're gonna remove this edge, and also you can see here we have parallel edge between the vertices B and C. So here we're gonna keep the lowest weight, so that means we're gonna keep the weight 8, and we're gonna remove this edge with the weight 10. So we are done with the first step. Now second step is to sort all the edges in non-decreasing order of their weights. So that means we're gonna sort these edges of the graph according to their weight. So first of all we have this edge with the weight 1, so we have the edge CF with the weight 1. Then we have this edge AB with the weight 2. Then we have this edge BD with the weight 3. Then we have this edge EF with the weight 4. Then we have this edge AD with the weight 5. Then we have this edge BE with the weight 6. And also here we have the edge FG with the weight 6. And here we have the edge DE with the weight 7. And then we have this edge BC with the weight 8. And lastly we have this edge CG with the weight 9. So here we have sorted all of the edges by increasing order of their weight. So next all we have to do is pick the smallest edge and we have to add it to the minimum spanning tree. And also we have to make sure that there should not be any cycle in our minimum spanning tree. So this way we have to repeat the process until v-1 edges are included in our minimum spanning tree. So we are talking about this number of edges. So in our sorted list, first of all we have the edge with the weight 1. So we are talking about the edge CF with the weight 1. So in our minimum spanning tree we're gonna include this edge with the weight 1. Next we have AB with the weight 2. So we have to include this edge with the weight 2. So next we have BD with the weight 3. So we are talking about this edge BD with the weight 3. Next we have EF with the weight 4. So we're gonna add this edge EF with the weight 4. So you can see in case of this Kruskals algorithm, first of all we connect all the edges, and in this process you can see the tree can be disconnected. But in case of Prim's algorithm, the spanning tree will always be connected, but the end result will be same. We're gonna have the spanning tree with the minimum weight. So next we have the edge AD with the weight 5. Now if we take this edge, you can see we're gonna have cycle. So as we know, there should not be any cycle in our minimum spanning tree, so that means we cannot take this edge. So we cannot take this edge AD with the weight 5. So next we have the edge BE with the weight 6. So we're gonna take this edge with the weight 6. Next we have FG with the weight 6. So we're gonna take this edge FG with the weight 6. So now you can see our minimum spanning tree is ready because all the vertices are connected using the edges. So in our graph we had a total of 7 vertices. So that means in our minimum spanning tree we should have a total of 6 edges. And if we count, you can see here we have 1, 2, 3, 4, 5 and 6 edges. So that means this will be our minimum spanning tree. So that is the Kruskal algorithm. So hope you understand the concept. See you in the next one. Take care.